Sometimes you just have to shake your head at the doctor's silliness. As you can see, guys, nothing has changed between the 3 degree of freedom motion sim platform build and the 4 degree of freedom motion sim platform build. You're still going to get the doctor being a little bit silly because he just can't help himself. Welcome back to the channel. Welcome back to all those who have been hanging in with the doctor since the 3 degree of freedom motion sim platform. I really appreciate you guys tuning in. I really appreciate all who have subscribed, and for any newcomers watching the Dr ADHD build tutorials for a motion simulator platform, welcome aboard. Thanks for subscribing in advance, and I really hope this helps you out. So this is tutorial 1, guys, of the new Dr ADHD 4 degree of freedom motion simulator platform build. So guys, we've got a lot of work to do, alright? So let's roll up our sleeves and let's get building the Dr ADHD 4 degree of freedom motion sim platform. Let's have a very quick overview of what you're getting yourself into with building this 4 degree of freedom motion sim platform. This sim platform is made from a combination of 30mm by 30mm by 2mm thick box, 25 by 25mm box of 2mm in thickness, and I also use Merbau hardwood timber decking to mount all of the motors, and anything that connects the motors to the steel frame is isolated with decking. This has been used for the last 12 months, and this sim, guys, as you've seen in the demo, this thing will shake your teeth out when you've got the heave and everything ramped right up in Sim Tools. All the movement and the timber decking, if it's hardwood, if it's a hardwood Merbau timber decking, it is up for the task well and truly, and will save you the issue of having to pull your motors apart and isolate the earths, which is what many people do, but it's not a good idea, guys, to isolate your earths anyway, period. Grounds are grounds. Electricity is always going to find a ground somehow, and all you'll do is you'll end up heating your motors up by doing that anyway. Your motors will just run hot because they won't be able to ground themselves properly. So these are a case ground motor. All the motors that I use are case ground anyway, so I can quite easily just put them on some timber, isolate them from the frame, isolate them from each other. Then they can't send current to each other, or no current can get back to your electronics and take out your motor controllers, because ultimately that's what happens. Because what happens with a motion sim is, instead of motors just going in one direction the way that they've been designed, we're commanding them to move forward and reverse. That reverses the polarity of the current that's going from the motor. Your grounds become positive and not just negative, and therefore they end up charging your frame. Those grounds end up getting back to your controllers basically, and they'll take out your controllers. That's the idea with the Merbau bracketing. I've made all of the elements of the rig, the seat, the steering wheel frame, the pedal cage, everything is adjustable by using 35 by 35 sleeve overs over the 30 by 30 box for the top frame. That means that our pedal cage can be moved forwards and backwards. The steering wheel frame can be moved fore and aft, and it can be moved up and down, so you can adjust its height. The seat's completely adjustable. It can be moved forward and backwards. The seat is on this spring setup here, guys. So then basically it helps amplify the heave that you feel in the road surfaces. It works really, really well. Brings the heave through from the front motors actually to your body in the rig. So the seat's completely adjustable. I've just used basically a cheap television bracket here at the front. I've modified that to basically take my mouse and to set up my keyboard. That's what that's all about. I use a lot of 75 by 25 box. Here's where the emergency switch will go. It's what the joystick's sitting on. It's what the uni joint here attaches to the top frame. There's some 75 by 25. It's what the pedal cage is built from. 50 by 25, sorry, not 75 by 25, 50 by 25 box. They're all made from that. So it's those elements, guys, that the rig is made from. Our rear traction loss axle here is some 40 by 40 by 3mm thick. It's a very strong piece of box. So that's really how it's all set up, guys. That's what you're getting yourself in for. But this has been running now for a little bit over 12 months, running flat out. And it's relatively simple in its design, but it's very effective. Okay, guys, what you can see before you here is pretty much the elements that are required to build our mid-frame of our 4 degree of freedom motion sim platform. The mid-frame is probably the most critical component of the 4 degree of freedom motion sim platform. It enables our platform to carry the top frame, to couple with the base plate, and it allows our mid-frame to pivot, guys, so we can experience yaw if we're in our flight sims, or traction loss if we're in our car sims. And the new trolley rail system, guys, here's a prototype that I built earlier. It's a more heavy duty one, the one we're building for this. With this new trolley rail system, there's two of these, one for the front motor mount bracket, and of course our uni joint, guys, which allows our pitch and our roll, all right? So these are the elements that are required. Our timber hardwood Merbau here, which carries our motors and keeps them isolated from all the other metal components, so we don't have issues with our IBT2 motor controllers. We'll be going through all of this, guys. You don't need to isolate the earths in your motors like you may have seen some people with motion sims do. You don't need to do that, guys. If you're smart and you select a good hardwood decking timber, then you don't have to pull your motors apart, which is a very good idea because you don't want to be isolating earths in your DC motors. This is in essence what you need, guys. A heavy duty pivot caster for the front of the sim to allow it to pivot. Here's our 75 bearing insert casters. They must be a bearing insert caster. This is for our traction loss axle. Some 40 by 40 by 3mm thick box for our traction loss axle. Here's our mid frame, guys. It has been downsized from a 100 by 50 to a 65 by 65 piece of box. We've got some 3mm 40 by 40 angle here, guys. This is our trolley rail system that will take our new carriageway for our surge axis. Some 65mm by 35mm box, guys, for our front motor mount bracket. You'll require some 75mm by 5mm thick flat steel. Already mentioned the Merbau. You're going to need nuts, you're going to need bolts, you're going to need washers. I'm going to make you aware of all of this sort of stuff. When we get to the element that we're going to build, guys, and the parts required, I will go through in detail what it is that you need to purchase to build that particular component. Today we're going to start with getting a hole drilled in our mid-frame so we can run our wiring through our mid-frame. The mid-frame is a great conduit, guys, for running the rear traction loss and the rear surge motor. The wiring for both the potentiometer and the motors can come through our mid-frame to the front of our motion sim, where our electronics box will sit with our IBT2 controllers and our Arduinos and our power supplies. Okay, they'll all be at the front of the rig. Okay, guys, let's get building and let's start talking about what we need to understand about measuring, marking, and cutting our metals. Let's talk about the basics of what you're going to need to measure your materials so then you can mark them and cut them, all right? I'm going to talk about measuring and marking. And this will be for every element of the build, guys. You're going to need a tape measure, all right? I recommend a minimum of a 6 meter tape measure. You should get yourself some metal tech rulers, guys. Here's a 600mm in length tech ruler. This is a 300mm length tech ruler. And I have a 1 meter tech ruler, guys, with bubble gauges. Very handy. Not necessary, but handy, okay? Tape measures can be a little bit inaccurate, particularly if your rivets in the end start to wear, and they can wear very quickly, guys. They can wear within a couple of weeks, and they can end up being out by a couple of mil each time you're measuring. So you need to keep an eye on that. So you will need a 6 meter tape measure. You just need to keep an eye on the rivets, okay? Digital veneers, absolutely critical, guys, to make your life easy for accurate measuring. Or indeed, you could have something like this tool that the doctor made back in high school. This is basically for measuring linear lengths of metal to do one big mark. We need to do that with our mid-frame and with a couple of other elements where we're measuring large sections, guys, to repeat either drill holes or welding locations, etc. Veneers do the same thing. They're a little bit easier to set up than something like this, because this we need to use a ruler to move this to our location, whereas veneers have got it all. So you can buy digital veneers very cheap off Fleabay or Amazon. Get yourself a set of those, guys. They're going to be invaluable to get accurate measurements. You are 100% going to need a set of squares, guys, different size squares. And make sure you get at least one of your squares with at least 20mm footprint to run against your metal. When we're using RHS box, which is what we use a lot, box has rolled edges. So if you get narrow squares, now these will be all right for flat steels and some of our solid steels, okay? But when you come into large RHS box, you need a good footprint, guys, so when you put it on, it doesn't roll off the edge, okay? So that's my recommendation there. Just a good old-fashioned mathematical protractor. We need that to set up our caster angles on our traction loss plate, and an angle finder checker is extremely handy as well. All right, marking our metals, guys. A metal scribe, extremely accurate, very important. Great for marking metals with rust or with primer and paint, okay? A sharp lead pencil, you won't go wrong with that as well. Or a sharp Sharpie, guys, but it has to be a fine tip Sharpie, excellent as well. I would be getting one of each of those, and that will pretty much see you through everything that is needed for your marking in this build. If there's anything else that's required, guys, I'll take you through that. So the backbone of our mid-frames, guys, is our mid-frame spine. Now this is a solid piece of 65mm by 65mm by 2mm thick wall box, RHS steel box. It's a mild steel. Do not get this or any of the metal items that we'll be working with in galvanized, okay, guys? We avoid galvanized. It is an extremely volatile metal to weld and extremely dangerous to weld. The fumes it emits when you weld are extremely dangerous. Stay away from galvanized metal. All your metal that you will select for this will be a mild steel, and it will be primed, ready to paint. Now, this is my recommendation, guys, for something like the mid-frame and the bottom plate, which have some reasonably long runs, okay? You're going to be fairly limited with the lengths of the metal and the sizes of the metal that you're going to be able to acquire. So really you need to get yourself friendly with your local metal merchant, your local metal shop, okay? Now the beauty about that as well, guys, is that all of those shops have guillotines, they have horizontal band saws, chop saws, they've got all that sort of stuff, and for a couple of bucks, you can have them cut your metal to size, all right? Now, any of our small components, I'm going to take you through how to use an angle grinder and cut all of those things, okay, yourself. But for big pieces like this, if you've got to go and purchase it anyway from the metal shop, you may as well get them to cut it for you to the size you want. It'll save you a lot of dramas, and you'll be able to fit it in your car a lot easier as well, right? Occasionally I'll go to the hardware shop because it's not too far from home, because it's convenient, but it's always more expensive and I can never really get what I want. So make yourself acquainted with your local metal supplier, okay? We are going to require a length of 1400mm, all right? That is the length of our mid-frame. The first thing I'm going to do, guys, when I get my piece of metal home from the metal shop, right, is I'm going to check where it's been cut. Now, generally speaking, because they've used a horizontal bandsaw or a chop saw, it should be a square cut, but there has been times when I've brought my metal at home, so I actually take these with me now to the metal shop. They all roll their eyes, but I do it because I've been caught a couple of times. You might get a young guy who's new to the shop or whatever, and he doesn't really know what he's doing, and he ends up cutting your metal crooked, right? We don't want that. You may as well be anal about this, guys, at the start and get yourself into good habit. So I always take a square and I always put it on the end, right, and I always check that the piece has been cut, all right, because I'm going to make measurements off these faces, right, and if it's crooked, you're going to have measurements that are not correct. They're going to be longer and shorter, all right, so I always check. It's what we have to do, guys. We have to check and we've got to measure. So I always check and make sure where it's been cut is square, so when I do my measurements, I know my measurements are square, right? Now this is a piece of 65 by 65 that has not been cut to the correct length because I've got some other projects and I needed a bit more. So I'm going to be cutting this in my workshop. Okay, so for those that would prefer to save money and learn to cut metal straight just with an angle grinder, it can be done, guys, if you're smart. I'm going to show you how that's done now because you'll apply this principle to everything that you cut in this build. So we're going to go through that just so it's done. I've got my better tape measure here that doesn't have the wonky rivets on the end, so this is going to be an accurate measurement. And the first thing we're going to do on our mid-frame, guys, before I cut it, I'm going to make this measurement because we'll be drilling a hole right in the center of this because this piece of mid-frame, guys, will take our wiring, as mentioned before, from our two rear motors, our surge motor and our traction loss motor. So we need to get a hole in our mid-frame ready to get a grommet in it, guys, and ready to run our wires when it comes time to connect up our rear motors, all right? So the first measurement that will be made on this mid-frame, guys, will be at 250 millimeters from any end. If you've got a virgin piece of spine here at the moment, it doesn't matter which end, but this measurement, this will become the rear end of your mid-frame. 250 millimeters. Now I'm just using a pencil for this measurement, a sharp pencil, which comes through really nicely on that, okay, and I'm just going to cross that, all right? So I know that's where it is. I've got to center it, but I know that's the distance from the back that I need to drill my hole. Now, because this is not cut to its length, I'm going to measure it now so I can cut it to its length. Your mid-frame for the Dr ADHD 4-degree of freedom motion sim, guys, is 1400 millimeters in length, all right? I'm not sure if I'm still in the shot here. I may not be. Let's move this forward. Okay, now using a tape measure, guys, okay? Tape measure is only going to be as accurate as, like I've said, of its structural integrity. And also, guys, the way you measure with it. Don't measure with your tape measure crooked, all right? Make sure it's straight. Those little measurements like that will put you out 1 or 2 mil, and guys, it all adds up. And some elements of this build, you can't mess that up, okay? So make sure your tape measure is straight, 1400 millimeters. There's our mark. Now I'm going to change over to my scribe, okay? It's too easy to lose my pencil mark, and the scribe, I'm not going to lose this mark once I've scribed through this primer. Rightio. Here's a classic scenario of what you would do to measure a piece of box to get it so that it's cut straight when you cut it. I will take my larger square with a 20 mil footprint because I don't want it to roll off the rolled edges of my box. I'm getting that on that mark, right on that mark, okay? And I'm marking that in. Now, next face. Exactly the same deal, guys. 1400 millimeters. Tape measure straight. Okay, getting my square on, making sure my square is nice and firm. Oh, the doctor's had an absolute Barry Crocker. Got to keep it on the ruler. Okay, I'm getting that marked in nice and straight this time. All right. This happens, guys, from time to time. Just get in another mark, all right? You'll know that it's obvious which one's crooked and which ones you don't cut to. 1400 mil. Now the doctor does have the luxury of having a large horizontal bandsaw. I've got a chop saw, etc. So really, I'm just going through this exercise for you guys because not everyone's going to have that kit. And the 3-degree of freedom motion sim platform, I went through that, guys, step by step for people to use all hand tools. So an angle grinder, hand drill, the whole works. I showed how all that stuff can be done, the techniques to use for using these items. So I'm going to do this with the 4-degree of freedom as well because there'll be a lot of new people tuning in to this video, guys, to build this 4-degree of freedom motion sim. So I'm going through everything afresh. Okay, this time we'll make sure that our scribe goes hard against our ruler. Okay, one more face. 1400 millimeters. Now I apologise to my American friends and I appreciate you guys who tune in. I really do. You're going to have to use that metric to inches converter to work this stuff out. And guys, if it's not exactly right, I know this is going to be hard, guys, with hundredths to the inch to hundredths of the millimetre, etc. Something like this, guys, in the ballpark, within a couple of millimetres, is not going to make any difference. But anything that is critical, I will let you know. So before we go crazy, throwing sparks and weld splatter all over the workshop because we're working with metal, metal. Let's talk about some 101s on gear that we should wear to look after ourselves in our workspace, okay? Because you do not want to be getting around in a mankini or it's going to be hell to pay for your balls. Something to protect your genitalia, like long pants, cotton drill pants, right? Cotton, not nylon, okay? Cotton drill pants, long sleeve, cotton drill shirts, a good pair of leather boots. Now these ones happen to be steel cap, pretty handy, guys, when we're working with metal. You don't want to drop a big lump of RHS box or something on your toes, you're really going to know about that. We'll talk more about hands, face and stuff like that as we get to the specifics of our angle grinders and our welders and our drilling. But just the basics for now, guys, before we go forward. Got to have this stuff to look after yourself in your workspace. We'll be doing a lot of cutting of our metals, and you'll be able to do everything you need to do throughout this motion sim build with a good old-fashioned handheld angle grinder. Now, this is just a very cheap Chinese-built 125mm corded angle grinder. It's about 1500 watt. It's got plenty of power. This brand here in Australia, this is found at our big hardware chain here called Bunnings. And this is equivalent to what you would get like as a Harbour Freight item, for example, in America. Just a cheap Chinese angle grinder, but I have had this, I'd say going on almost 10 years I've had this angle grinder, and it's done a lot of work. It's still going. Now you'll notice that it doesn't have a guard on it. I remove the guard off my angle grinders, guys, because I'm an absolute tight ass, and I try to use all of my disc. Now, you can do that. It's highly risky. You've got no protection from coming into contact with your blade if you do that. So I do not recommend that you do that, guys. Keep the guards on your angle grinder. But this is all you need. I think this cost me around 49 Australian dollars when I bought this. And it's been a pretty good grinder. It even came with a spare set of bushes. So when the bushes wear out, I can replace the bushes. At the moment, it's still going. It's getting a little bit noisy because the bearing's starting to wear out, but it's done a hell of a lot of work, and I've been pretty happy with it. Now, how do we use our angle grinders? We're going to do this right from the basics, guys, because I'm going to assume that there might be people watching the channel who have never even used an angle grinder. Fair enough. We all have to start somewhere. So I'm going to talk about how you change your blades. I'm going to talk about what I believe are basically the fundamentals that you need to get this build done, to clean your metals, to clean up your primer, to clean up your metals for welding, and for selecting the right materials for your cutting. So first and foremost, guys, you will need a cutting disc. You'll need a set of cutting discs. Here's a 12-pack that can be obtained from, once again, that wonderful store here in Australia called Bunnings. This was about $18 or something like that for a 12-pack of 125mm multi-steel cutting discs, all right? Select thin cutting discs, all right? This is a 1mm, okay, 1mm thick cutting disc. So that will actually remove a millimetre of material if you think about it. You need to take that into account when you're cutting. So we'll talk about that when we come to marking and cutting. So you'll need a set of thin 1mm cutting discs. You'll need a set of grinding discs. We don't use these that much. This is going to be more if you make a mistake with your welding and you do a big chunk of weld, a cold weld or something like that. And when you first start welding, you've got to expect that's going to happen sometimes. It'll get to the point where you won't need to grind your welds anymore, okay? But for a little while, you may need to grind some of your welds off because they might be a little bit wild. But you'll get better as you develop muscle memory for your welding. So you'll need grinding discs. What you will use the most, guys, and the most effective disc that I find for working with all of my metals are these sanding pads, all right? These are awesome, okay? They're fantastic for removing mill scale, primer, rust, and just cleaning stuff up ready for welding. They will also grind, guys. They will actually take material out. You will use this a lot faster hunking into metal with it than you would with a grinding disc. But they're a lot quieter. And they're just really, really good, okay? So there's a pack there, for example, that I bought from the Aldi chain supermarket here. They sell tools and stuff sometimes. That was a 4-piece. I think it was like $15 or something for 4 of these. And I use these a lot. They're excellent. How do we work with these different materials? Your angle grinder, guys, it has a locking nut here that holds your discs on, all right? On the back side of your angle grinder, any angle grinder I've ever used, there's a little locking mechanism here, right? This locks your spindle to stop it from turning. See how that free spins at the moment? If I press that button and then rotate this a little bit, it'll lock this, okay? Angle grinders come with a key that inserts into these holes here on the locking nut, all right? So by holding that button in at the same time and keeping this locked, you can release that lock nut. Now you'll notice at the moment on my angle grinder I have a cutting disc, okay? I've got the flat cutting disc on here at the moment. You'll see this little disc here that fits on the back side of the angle grinder here. It has a machined surface on the top here, and it's got a machined top, all right? And it's got some machined cutaways, some keyways here that fit in, some cut-out keyways here on the angle grinder shaft. Just be careful of this. This is easy to lose if you're not thinking about it and you take this lock nut off to change a disc. This can fall off and go walking around and getting lost in the abyss of your workspace. So just keep that in mind. They come off. That always has to be on the bottom, guys, and the keyways lined up with the keyways on the shaft. Your flat disc or a cutting disc, in this instance, it goes around this machine surface on the bottom disc. All right, see how it locks that in? So I can't move. Put that back on. And your top lock nut, guys, disc, it also has a machine surface. Now in this case, we put this on the flat side for a cutting disc, because as you can see, that flat disc sits flush around that machine surface on the bottom. So therefore, this will sit down once it screws on, right? And once you lock this in place again, take your key and tighten this. Don't over tighten it, just firm. That can't go anywhere, all right? So that's how a cutting disc goes on an angle grinder. Let's take this off again. You can actually just undo these by hand. Most of the time, guys, and I'm wearing leather gloves all the time when I'm doing my angle grinding, I can just do things hand tight. And you can just touch that. You don't ever even really need your keyway. Things can be done by hand. You've got to be a little bit careful with cutting discs, doing them by hand, because they've got a lot of flex. You can break these and then they're no good. And these things aren't super cheap. So we need to be careful doing cutting discs by hand if that's what you're going to do. Okay, grinding discs. Now these are a different animal. See how they've got a raised surface around this area? Right, they will go on like this and they fit over that bottom machine surface. They lock in. See how there's a lot of space here and how this is elevated above where we were before? Well, our lock nut on the top, in this instance, where it's got the machine surface on the top here, it doesn't go on the flat, all right? If you put that on the flat and tighten that up, this will move all over the place. It'll rock and roll. It'll be an absolute shit show, all right? This needs to go for a grinding disc. The machine surface goes down and it slots into that area that's available in the top of this disc, right? And it stops that disc from being able to move at all right? Keeps it locked in. That's how that grinding disc is placed, and you will do exactly the same for this guy here. Actually, sorry, this one here, you put it flat like the cutting discs. All right, just be a little bit careful tightening this up. Depends on the make of these flat discs. The locking disc should just contact that metal part on the bottom. It shouldn't be contacting the fiberglass here and basically compromising its structural integrity. And it just goes on like the cutting discs, all right? So that's some 101 on your angle grinding, all right? Don't remove the guard. What do we need to look after ourselves with our angle grinding? I highly recommend, guys, that you get a set of good quality leather rigging gloves. You're going to need these for welding, absolutely 100%. And I use these when I'm using my angle grinder. You do cop a lot of sparks on your hands when you're cutting sometimes. So a good set of leather gloves. And plus, guys, when you're cutting, your metal heats up, all right? Metal heats up and it transfers heat very easily, and it can get very hot when you're cutting it, and you'll burn your fingers very easily. So I end up using leather gloves a lot around the workshop. I only take them off when I've got to do sort of, intricate stuff that it's a bit cumbersome if you've got gloves on. Otherwise, I've got my gloves on a lot. The other thing you're going to do, guys, I hate to say this, but you are going to cop a lot of metal shards and a lot of metal burrs and splinters a lot. So get yourself a pair of tweezers and have them handy in your workspace. You will need these, guys. I, being an old decrepit bastard, I use a set of these these just go over your head, magnifying glasses, and I use these frequently. Not, to find splinters. I also use these when I'm soldering, when I'm doing my wiring and stuff like that, because, as I said, I'm old. My eyesight's not as good as it was. They're excellent, and they're excellent in conjunction with a head torch, okay? You can wear them both together. You get excellent light, you get excellent magnification. You'll need that sometimes, guys. If you're a young person, you may not need that, but you'll cop metal splinters. Trust me, it's just a byproduct of what you're doing working with metals. Especially when you're drilling, you'll get a lot of metal shards, you'll cop splinters. The other thing that is ultimately important, guys, is a face shield, and a full face shield. Let me give you an example of what happens if you don't wear one of these. For years, I wore just simple safety glasses when I was using an angle grinder, and I did that for 20 years without any problems. Until around, maybe it's going back 2 years now, 2 years ago when I was grinding some metal. I think I was cutting it actually. I was cutting a piece of metal, and I copped a splinter, a metal splinter in my eye that came through the side of my glasses. Okay, my glasses weren't sufficient enough to stop this particular splinter. I didn't think much of it at the time because over the years I've copped a lot of metal in my eyes. Normally it just comes out after a couple of days. You go and flush your eyes or whatever. This was different. It just got worse and worse. And after about 3 days, I mean, the doctor's not the greatest fan of going to the doctor or a hospital, but in the end I had to because it was just getting so painful I couldn't sleep. I went to the hospital, and guys, I had a full splinter that had embedded itself into my eye, and it had started to rust in my eyeball. And that's what happens. You end up getting a rust ring in your eye. And I had to have several sessions then to a specialist to have my eyeball ground. That's right, they put a little mini grinder on my eyeball, I think it was 3 or 4 different occasions. They have to remove that rust ring, otherwise it can blind you. So a full face shield is 100% necessary, guys, to really look after your eyes, okay? Get a full face shield and have that on every time you are working with your angle grinder. Rightio, let's talk about how we're going to go about cutting this metal and cutting your box really square, all right? Now, what I was going on about previously, guys, about marking every face of your box to get a square cut. Now, if you don't have the luxury of a drop saw or a bandsaw that's going to cut it pretty straight, this is the only way really to get a guaranteed cut straight when you're cutting box, whatever the size is, all right? And this goes for flat steels or whatever. With flat steels, you'll have this marked, you'll have a square on it, you'll have it marked, and you'll be cutting along those lines straight, all right? Cutting discs, okay? They have flex in them. That's why you can't just make one mark and try and cut down through a piece of box with that. I guarantee the disc will flex and you'll end up cutting a crooked cut, all right? So if you mark every face of your box, you will just cut face to face to face of where you've marked, all right? And then you'll get a square cut. Now, when it comes to cutting flat steel, and we use quite a bit of flat steel in this build, once you've got your lines marked in, right, as we'll go through, as we get to the different elements of the build, you'll just gently run your disc along, all right? Back and forwards, along the cutting area where you've marked it. You won't use excessive pressure. You let the disc do the work, let the weight of the grinder do the work, and just nice and gently back and forwards, okay? Now, with large length or you know, with wider material, you're going to be able to do a reasonable amount of oscillation. With small pieces of box, which mostly we use other than our mid-frame, you won't need to oscillate on those things so much, okay? It's just more going to be a nice cut through that side of the box, then move it around to where your next mark is, cut through that side, and you'll get good plumb square cuts if you measure your metals on every face where you've got to cut them. So that's some angle grinding 101. Well, that is your lot for today. So until I see you in the next tutorial, you guys stay safe, stay healthy, and take it easy out there.